Hello, my fellow YouTubers. I want to give a shout out to some of my peeps out there. Energy Crafts, thanks for leaving your comments on my last video. Jay Decker, Tommy, Lloyd McGrath, and my boy Honda. We'll go over some of the comments you guys left. Some just left some left information for me to check into for another video, and we'll jump into that. But the last segment of this video will be about the vibration of the core that we experienced last night on the other video, or on the last video. But we'll jump into it, and this is an update on the generator, in case you guys ever want to build one at home. We'll have something to follow. So we're going to start off right now on the checking the ohms on the stator, on the center stator, and let's go ahead and put it over to the lowest ohm setting. And let's disconnect some things here. There's some cool stuff here. You guys are going to enjoy this. All right, so for the stator, hopefully you can see that, right? Just touching together conductivity. One end will go to where the wires are tied together, and one will go over here to, I guess, all three. There we go. So we're going into one leg. All right, so you got 5.5 times 3. So you'll have 5, 10, 15, 16 and a half ohms for all three phases. You got some resistance built in there. Now we got all three of these legs over here coming out of the, each one of these are a phase. So I got them all tied together with the negative side of the DC power supply coming in on that side, and this side we got the positive that's coming in. And why do we have that set up like that? Inquiry minds want to know. So, that's the resistance that's on this stator right here. Okay. Now we're going to go ahead and we're going to check the ohms on the new coil. Well, here's the new coil. And the ohms on the new coil on this coil here is reading 0. So we have 18 gauge and we're barely reading 1 ohm, okay? So we're in milliohms, if there's such a thing, probably is. So I'm making these with no resistance. That's the game plan. And we'll go over why that's the game plan when I get into that side. So you have each one of these phases was 5.5 ohms, pretty good resistance. You got 3 phase here, you got A, B, and C. And then you got 5.5 ohms, 5.5 ohms, 5.5 ohms resistance. On these coils here that are going to be placed on the outside directly in front of each one of these are 18 gauge, about 40 turns times 6, about 240 turns, and still can't get any resistance out of it, barely any resistance. But that's actually good because we're going to show how we're going to add resistance to those coils. But I want those coils to be the stronger coils. Now let's go ahead. We're going to hook up some power to this, and we're going to check with the compass. And what I want to do is I want to check to see what direction these are wound in. Because I want those to be south facing out. So these here will be south, and the ends of these coils will be north. Okay? So that'll be south facing out. So let's go ahead and get the compass. And we're going to see if you guys can see the compass. Get you right on there so you'll be able to see. Okay, so let's go ahead and hit the power supply. We got 3 volts. Let's bring it up to a good 12, 13 volts. And let's check the compass. Here we can see it's south. Yeah, we got spark. So that's firing up all 3 phases at one time right there. And we have south. Okay. So now, let's get you closer. Like this. And let's take this coil and fire it up and check the polarity on this coil. So you can see the compass there. And you can see this over here. And this side is going to be a strong north. See it pull north? There we go. So you can see it's north. Now, take a peek at, let's get the voltmeter in play here. I got the voltmeter. Hooked up to this coil, and we're going to check the magnetic field lines coming out of that coil and see where the strength lies in positioning that coil, because that coil is going to be one of many coils that go around this wheel, and I want to see the angle of the field lines, and you'll see it through the strength. So we're going to go ahead and we're going to take it's just like that. Okay, we're going to take that's what we're dropping to right now, and we are on. Now take a look at the voltmeter. Let me do something here. So you can see stuff popping up on the voltmeter. You can see where we're cutting the field lines here. And this is getting very hot in my hand because there's no resistance. Now what I want to do now is go ahead and we're going to add some resistance. So if you look up on my up there, these are all resistance with resistance wire. So the first run is 5 ohms, 10 ohms, 15 ohms, 20 ohms, 30, 40, 50, 60. So I got it tapped about almost halfway, so 2.5 ohms. And now we're going to do the same thing without having all that current running in there. We're going to add a little resistance. Okay, so I got the positive going to the bottom side of that start of the wire. And then we're coming off of that black wire. Now we're going to go ahead and fire up the power supply. You can just see we tapped that. Now we're going to come over here. Let's get you back down here. Now I have this hooked up to the resistance, not getting hot anymore. And now look at the voltmeter, is doing even better. There's resistance in there. Now we're gonna have these, remember the name of the game here, guys, is we're gonna have no motion in this wheel. We're gonna have transistors taking each one of these outside coils under different resistance to make a magnetic wave. But you can see the power showing up, the voltage showing up over there. So, let me see. I think we're down to, you got your conductor covered. Let's go down to the vibration test. Good old vibrator. So we're going to take this coil that we had last night and we'll place it right there. We want the power from the DC power supply. Yeah, Jay Decker and Energy Crafts got me thinking last night, and it did make sense. And let's do the study now and see what happens. So we're going to start off first with I guess we'll go right to this one since it vibrated. We're going to go ahead and get it to vibrate again. Then we're going to put a car battery to it and see if it vibrates. Alright, so we're going to do 10 volts. And we're going to take some sand. This. And fire in a hole. You guys ready? Let me get you closer. It's vibrating. Alright, so you can see it vibrating. It's also sticking. Should turn it down a little bit. There it is. Big vibration when you turn it down. Alright, so now we'll turn the DC power supply off. Now we have to bring over some authentic jumper cables. Jumper cables. Straight up DC 13 volts. Let's get you back over here. All right. Now we got regular car battery coming in. Woo! All right, let's get this with some stuff on it. Let's hold it over just a little bit. Whoa! Whoa! Wait a minute. There's your test. No vibration coming from the car battery. Straight DC. So what was going on was the Jay Decker had it right, and so did Energy Crafts, that we were draining. The load was so intense that because there's no resistance in here. So it was draining the capacitors in there. So it was getting actually AC in there. Pretty cool stuff. Never seen it happen like that before, but it made so much sense. And that right there, like this right now, is super hot. Just from pulsing it with the DC or hitting it like we just did. Hopefully you guys enjoyed the video. A lot of good information here. Excited about building this because remember, this ain't so much about following Mr. Clemente. What's his name? Clemente. It's a patent that he has, but I'm making great changes to it because I understand it a little bit differently and what I'm trying to accomplish with it. So we're looking to not only have a wave traveling, but it's going to be similar to the wave that's inside the PMH when the keeper bar is on. And it'll be continuous, infamous, except for when you release the keeper bar, the energy runs out the coil. Here, the goal is to take this stator and cut it straight in half. And one half, we'll do it this way, vertically. This half is the first set of cycles, is the half cycle. The other half makes everything go backwards. So basically it starts off high here and then low down here, and then it starts off low and goes back up high. So this timing system will be through a controller that I'll build without asking what kind of controller to use. I'm going to design a controller that is going to be somewhat set up off of one of Tesla's patents on his feedback circuit. And what we're going to do is have each one of the outside coils that go around are going to be tied into a feedback. So the feedback will turn on and off the next 2 or 3 transistors. So we're creating, like if this was a roller coaster ride, every time my fingers are, when it's getting fired up from the transistors in doses of 3. So you got 3 phase here, so it'll be like this. It'll be always having, well actually always having 2 always connected. So 2 are going, then as it goes to the 3rd, we're leaving that one. So always dragging behind, and we're firing up. So the idea is to get the half cycle fired up. Once you get the half cycle fired up, the process will repeat through the other half of the cycle, and then it'll start over again. The idea here is we're going to put that into a tank circuit, into a LC circuit. And that LC circuit is going to take that energy and it's going to flip-flop the inductor, a coil. Outside here is a separate circuit. An inductor and a capacitor will be rotating as these rotate. Now, once I get the little light to light up, I know it's been charged. I'll attach a little light to the circuit and I'll know it's been charged, and then I can stop the power going into the machine. And at that point, as long as the light stays on, that machine is continually running on its own power. And then we'll have to dig into it from there and start pulling it apart and seeing if we could somehow put load on it and see if the load would have to come from where. And we'll check and see where, if the energy in the start of the system dissipates, then that's probably expected, what I'm expecting. But if it doesn't dissipate and it stays continuously going and keeps amplifying itself, that means it's making power. We'll figure out how to drain the power and what ratio and what rate we could drain the power, and we'll just keep doing tests. We'll keep beating down on it. Hope you guys enjoy the videos. These are specific, detailed videos I'm laying out there for you guys so you can make your own down the road or now. It's entirely up to you. Everything is dirt cheap. Just be careful. This is not real copper. These are aluminum with copper coating with a shielding on them. So the resistance is different. So that's why I chose to stick with this being the south side exposed and always on. It'll always be on. So I don't want to inundate that and burn that up. But the outside coils will be doing their magic and creating the dragging effect that goes around. Hope you guys enjoy it. Peace out.